Hello students, welcome to section 6.3, and today we'll talk about ways to prove a quadrilateral is a parallelogram. In other words, we'll talk about the converse of section 6.2. In 6.2 we talked about the properties of a parallelogram, and today we'll reverse it. So one way to show that a quadrilateral is a parallelogram is to show that both pairs of opposite sides are parallel. And how do you show that lines are parallel? You will use slope. Okay, so we're gonna use slope, and if the slopes are the same, two lines are parallel. The next way to show that they are that parallelogram is both pairs of opposite sides are congruent. So how do you show that segments are congruent? You will use distance formula. Distance formula. Okay, you can also show that one pair of opposite sides are both parallel and congruent. So you have to show slopes and use distance formula. Number 4, diagonals bisect each other. Okay, diagonals bisect each other. So how do you show that diagonals bisect each other? You will use midpoint. Okay, and we can also show that both pairs of opposite angles are congruent, which is not easy to do with our skills. But again, if you can somehow show that both pairs of opposite angles are congruent, you can conclude that the quadrilateral is a parallelogram. So in this video, I will show you 3 examples. How do we apply this in coordinate geometry? Okay, so example number 1. Graph quadrilateral KLMN with vertices K 2, -3, L 8, 4, M 7, -2, and N 1, -3. Determine whether the quadrilateral is a parallelogram. So the question I have for you, is it a parallelogram? Well, it may not be. Justify your answer using slope formula. So when I say slope formula, you will try to show that the opposite sides are parallel. So let's start the points. K 2, 3, assuming the scale is 1 by 1. So 2, 3 would be here. You also have L 8, 4. So L is 8, 4. N 7, -2. So N is 7, -2, and N 1, -3. So N will be 1, -3. I will connect the vertices, and I will use different colors. Okay, so I will use blue here, and I will use red over here. So my goal is to show that the blue segments are parallel, and also I will try to show that the red segments are parallel. So let's start with the slope of line KL. So in blue, slope of line KL. Slope is rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So KL will be 8 minus 4 divided by 8 minus 2. Sorry, 8 minus, mistake. It would be 8 minus 3 divided by, looking at wrong numbers, 4 minus 3 divided by 8 minus 2. So this would be 1/6. Okay? 1 over 6. Now, I will find the slope of line NN, and I hope it will be also 1/6. So this would be -2 minus -3 divided by 7 minus 1. -2 minus -3 will become -2 plus 3, which is 1. And 7 minus 1 is 6. Okay? So this means that the two blue segments are parallel. So they are parallel. But in order for this quadrilateral to be a parallelogram, both pairs of opposite sides have to be parallel. So now, let's talk about the red segments. Okay? So now let's find the slope. Oh, I want to use red. Let's find the slope of segment KN. The slope of segment KN. -3 minus 3. Divided by 1 minus 2, which would be -6 over -1. So the slope is 6. Okay, technically means you go up 6, 1 to your right. Let's find the slope of segment LN. And in this case, it will be -2 minus 4 divided by 7 minus 8, which is -6 over -1. If you simplify this, it becomes 6. So the slope, both slopes are the same, which technically means that the two red segments are parallel. So the question was, determine whether the quadrilateral is a parallelogram, and the answer is yes, because both pairs of opposite sides are parallel. So the answer is yes, because both pairs of opposite sides are parallel. So I use algebra to show that the opposite sides are parallel. All right. So next example, we are trying to do the same thing. We are trying to decide whether the quadrilateral with the given vertices is a parallelogram. And in this problem, I will use distance formula. So in order to use distance formula, I will show that the opposite sides are congruent. Again, the first thing I want you to do is please plot the points. So A is 3, 3. B is 8, 2. C is 6, -1. And point D is 1, 0, which is technically our not x-intercept in this class, but in algebra 1, it will be x-intercept. So D is 1, 0. So again, I will connect the vertices using different colors. Okay, so I'm going to use blue over here, and I will use black color over here. So it's easier for you to see this. This is straight line, okay? So what is my goal? My goal is to show that the black segment is congruent to the other black segment. In other words, the two black segments are the same length, and also the two blue segments are the same length. So maybe let's talk about segment AB. First of all, before we actually do this, let's recall distance formula. So distance formula would be x sub 2 minus x sub 1 to the second power plus y sub 2 minus y sub 1 to the second power. Okay? And in other words, you can think about triangle Pythagorean term. X2 minus x1 is your wrong, and y2 minus y1 is your right. So let's talk about segment AB first. how would you find, let's use a ref, if I am consistent. So let's find the distance between points A, B. So if you want to find A, B, okay, you will do 8 minus 3 square plus 2 minus 3 square. If you simplify this, A minus 3 is 5, 5 squared is 25, plus 2 minus 3 is negative 1. Please remember, you are squaring negative 1, and negative 1 times negative 1 is 1. So this would be radical 26, which is technically a little bit above 5. Okay, so I will keep it exact, radical 26. So now, let's find the length of segment DC. Again, I hope when I do calculations, I will get also a square root of 26. Now, DC. Six minus 1 square plus negative 1 minus 0 square. Again, 6 minus 1 is 5. 5 squared is 25. Negative 1 minus 0 is negative 1. Negative 1 times negative 1 is 1. And again, I had radical 26. So, I have a pair of congruent sides. So in other words, AB, this segment, is congruent to this segment. So the two blue segments are congruent. But again, in order for this quadrilateral to be a parallelogram, both pairs of opposite sides have to be congruent. Both pairs of opposite sides have to be congruent. So I will erase this and I will show you the length of segment AD and the length of segment BC. So if you have to, please pause the video and copy this because I will erase it. So let's talk about segment AD. So AD, you will do 1 minus 3 plus 0 minus 3. And if you finish this, 1 minus 3 is negative 2. Negative 2 squared would be 4. 0 minus 3 is negative 3. Negative 3 times negative 3 is 9. So this will give you radical 13. Okay, you cannot give me decimal, leave it this way. And then I will find the distance between points C and B. And again, I hope I will get radical 13. So BC, I will have 6 minus 8 square plus negative 1 minus 3 square. 6 minus 8 is negative 2. Negative 2 times negative 2 is 4. Negative 1 minus 3. Oh, I made a mistake. I see it's not going to work. This is not minus 3. This will be minus 2. Minus 2. So negative 1 minus 2 is negative 3. Negative 3 times negative 3 is 9. And 4 plus 9 is 13. So this will be radical 13. So if you look at segment AD and BC, they are congruent. So they are congruent. So I showed you that the two blue segments are congruent, and two black segments are congruent. Therefore, ABCD, quadrilateral ABCD is a parallelogram. So I use distance formula to prove or to show that a quadrilateral ABCD is a parallelogram. So last thing you will do on your own, question 4B, you will be asked to show or to check whether quadrilateral FGHJ is a parallelogram using midpoint formula. So again, if you use midpoint formula, you will show that diagonals bisect each other. So your goal will be to show that diagonals bisect each other. Okay, and we did something similar in section 6.2. So thank you for watching this video, and I hope you understood all the steps, and have a good day.